Hi students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing this chapter called as UCM. We are going to do the numericals of UCM. Take down the sum please. Take down the sum please. A bob of a simple pendulum. A bob of a simple pendulum of mass 0.2 kgs. A bob of a simple pendulum of mass 0.2 kgs is held with a string in horizontal position. Is held with a string in horizontal position. Calculate the velocity of the bob. Calculate the velocity of the bob, the tension in the string, when it reaches the lowest point. When it reaches the lowest point. If the length of the pendulum is 1.2 meter. Now guys, let's assume that A is the highest point, B is the lowest point. Now at point B, the weight mg will be acting in downward direction. The tension T would be acting in upward direction, right? Now, let's start. Now, first of all, we have to find out the velocity of the bob at the lowest point. Let's first find out the potential energy of the bob. Potential energy of the bob at point A. Potential energy is always given by the formula mgl. So, I'll come to know the potential energy. Now, as the bob moves from A to B, the potential energy is going to decrease and the kinetic energy is going to increase. As bob moves from A to B, PE decreases and KE increases. Fine, do we get this thing here? Now, at the lowest point, B, PE will be 0, right? That means the velocity, let's assume that V is the velocity of the bob. Let V be the velocity of the bob at B. V be the velocity of bob at B, right? So that means I can say that potential energy at point A should be equal to the kinetic energy at point B. Potential energy at point A is mgl. Kinetic energy is half mv square. M and M gets cancelled. Therefore, I'll say 2gl under root is going to be velocity. That will give me my velocity at the lowest point. Fine, do we get this thing clear? Now, once you have this, next, they've asked you to find out the tension on the string at the lowest point. Tension on string at the lowest point. Tension on string at the lowest point, P, will be nothing but the weight of the bob acting in downward direction plus mv square by L. Right? Now, this is going to be your formula for this, because V square is nothing but, I can substitute, but V square is equal to 2gl, therefore tension is equal to mg plus m into 2gl upon L. L and L gets cancelled, so tension is equal to mg plus 2mg, so the tension on the string is going to be 3mg, right? You can calculate and get the answer. The answer for this should be, velocity should be 4.85 meters per second and the tension should be 5.88 newtons. Right? Take down next one please. A bucket. Take down next one please. A bucket containing water is tied to one end of a rope. A bucket containing water is tied to one end of a rope. Is tied to one end of a rope 6 meters long. Right? A bucket containing water is tied to one end of a rope 6 meters long and rotated about the other end in vertical circle. So they've given you that the radius is 6 meters. The length of the rope, let's assume this whole thing is the length of the rope, is 6 meters. It is being rotated in this circle this way. Fine. Find the minimum number of rotations. Find the minimum number of rotations per minute so that the water in the bucket, find the minimum number of rotations per minute so that the water in the bucket may not spill. Right? Let us assume that let V be the minimum speed of the bucket. If V is the minimum speed of the bucket, then I can say that centrifugal force is equal to the weight of the bucket. Centrifugal force is nothing but mv square by r. Weight of the bucket should be mg. Under this condition, the water will not spill, right? So in that case, m and m gets cancelled. So I'll get V is equal to square root of rg. So you will come to know the velocity, linear velocity, but we know that V is equal to r omega. Therefore, I can say r omega is square root of rg. Also, we know that omega is equal to 2 pi n. So r into 2 pi n is square root of rg. So in that case, I will get n is square root of rg upon 2 pi r. Right? Once you have this, you will get your revolutions per second. But they have asked you to find out per minute. This will give you the answer in terms of rotations per. Find the minimum number of rotations. You will get the rotations per second. To convert it into per minute, this will be n is going to be square root. This is in terms of per second. To convert it into per minute, you will have 2 pi r into 60. That will give you rotations per minute. That's how you come to know your rotations per minute. Right? Next. Let's see another sum, guys. A stone of mass 4 kgs. A stone of mass 4 kg is revolving in a vertical circle. A stone of mass 4 kgs is revolving in a vertical circle at the end of a string 2 meters long. At the end of a string 2 meters long. When the stone is at the top of the circle, when the stone is at the top of the circle, when the stone is at the top of the circle, its velocity is 5 meters per second square. Right? Yeah, continue please. The last thing that I said was, right? They've said that when the stone is at the top of the circle, the velocity is 5 meters per second. When the stone is at the top of the circle, the velocity is 5 meters per second. Assuming g to be 9.8 meters per second, assuming g to be 9.8 meters per second, find the force in the string, find the force in the string when the stone is at the top, second part at the bottom, third at level with the center. Right? Let's see this. What is the data given to you? They have given you that mass of the stone is 4 kgs. They have also given you that it is rotated in a string of radius 2 meters. Right? Now, they have also given you that the velocity at the top of the circle, is 5 meters per second. Okay. Now, let's consider the 4 points to be A, B, C and D. Okay. Now, let's try to understand this. Let's assume O is the center of the circle. Now, that means how is the force acting? The force is acting in outward direction. Right? I can say that the force acting outwards, that is along OA, is going to be equal to my centripetal force, that is going to be mv square by r. That is the force that is going to be acting in outward direction. I know m, I know v. They've given me velocity. V is given to me. R is given to me. I can come to know what is it. So mv square by r, 4. V is 5 into 5 upon r, 2. So this is going to be 50 newtons. That is going to be the force that is going to be acting in outward direction. Now, and the downward force, I can say that the downward force is due to the weight of the stone. Now the downward force is due to the weight of the stone. Now in that case, my downward force will be equal to mg, so which is going to be nothing but 4 into 9.8, which is going to be 39.2 newtons. Fine, do we get this thing here? So in that case, there is an upward force of 50 newtons, there is a downward force of 39.2 newtons. In that case, what will be the resultant force on the string? I can say that the resultant force on the string, I can say that therefore resultant force on the string is going to be nothing but 50 is the upward force, 39.2 is the downward force. So the net force that will act in upward direction is going to be nothing but 10.2 newtons. Fine, did we get this thing here? So the first part was find the stretching force at the top. So the stretching force at the top is going to be 10.2 newtons. When the stone is at the top, the upward force is 50 newtons, the downward force is 39, so that is the net force with which the body is going to move upwards. Now the second part of the question, find the stretching force at the bottom. Now by the time the stone reaches the bottom, it would have acquired a lot of kinetic energy. 10.39.2, yeah, 10.8, 40, okay, let's see this. Now by the time the stone reaches the bottom, it would have acquired kinetic energy. I can say that by the time the stone reaches bottom, it would have acquired kinetic energy, right? If it would have acquired kinetic energy, how much vertical distance it would have traveled? See, the radius is 2 meters, that means it would have traveled, guys, can you see this? Can you see this? The distance, vertical distance, how much is the vertical distance it would have covered? 2 meters here and 2 meters here. So the vertical distance that it would have covered is 4 meters. It would have acquired kinetic energy by traveling a vertical distance of 4 meters. Fine, do we get this in here? So in that case, what will be the kinetic energy of the stone at the bottom? Kinetic energy of the stone at bottom. Kinetic energy of the stone at the bottom is going to be, kinetic energy is equal to half mv square plus mgh, because the stone is not on the ground, it is in air, so there is going to be some kinetic energy because of its height. So in that case, the kinetic energy that it is going to have is half. Mass of the stone is 4 kgs, velocity is 5, so 25 plus m. Mass of the stone is 4, 9.8. Height, the distance that it has covered is 4, right? So you will come to know that the kinetic energy acquired by the stone is going to be 206.8 joules. That is going to be the kinetic energy. It has moved this vertical distance down, so that much potential energy is not converted, and it has moved through this path. So therefore the kinetic energy on account of motion, guys, let's see this, as it moves down, it is covering some vertical distance. So some part of potential energy getting converted to kinetic energy. Moreover, it is in motion, so that the kinetic energy also, so the total kinetic energy is 1 because of motion, B because of it moving down, right? Because of it covering a vertical distance, right? Now I can say that this kinetic energy should be equal to the kinetic energy at the bottom. Let us assume that v1 is the velocity at the bottom. If v1 is the velocity at the bottom, then I can say that this particular kinetic energy, that is the total kinetic energy acquired by the stone, which is 206.8 joules, should be equal to half mv1 square. That's the kinetic energy at the bottom, right? In which case I will come to know the velocity of the stone when it reaches the bottom, that is 206.8 into 2 upon the mass. Mass is 4, is v1 square. When I solve this, I will get the value of v1 to be 103.4 meters per second. That is the velocity that with which the stone will cross point C, right? Now if that is the velocity, now let us try to see what are the forces that are going to be acting at point C. Now at point C, the centrifugal force will be acting in downward direction. At point C, the centrifugal force acts in downward direction. If the centrifugal force acts in downward direction, then that centrifugal force will be mv1 square by r. Mass is 4, v1 you found out as 103.4, r, radius is 2, right? So in that case you will come to know that the downward force, downward centrifugal force is going to be 206.8 newtons. Moreover, the weight of the stone will also act in downward direction. So I can say that the weight of stone also acts in downward direction, which is going to be equal to mg, mass is 4 into 9.8. Therefore the total force that is going to act in downward direction is going to be the centrifugal force and the weight of the stone. Both the forces are going to act. So therefore the total force at point C, this was say 39.2 newtons. So this is going to be 206.8 newtons, that's my centrifugal force, and 39.2, that's my weight of the stone acting in downward direction, which is going to be 246 newtons. Fine. That is the force that will be acting in downward direction. Now, let us find out the force at level. Third part of the question is, find out the force at level. First, guys, see this. If the body moves from here to here, how much is the vertical distance it is going to cover? 2 meters. In the previous case, it was covering 4 meters, right? So let's find out. Here the kinetic energy is acquired by the stone. Kinetic energy is acquired by the stone due to it falling by 2 meters. Due to it falling by 2 meters is going to be mgh. That is the kinetic energy that is going to be acquired, and due to velocity with which it is going to be moving down, due to velocity is going to be half mv square. Therefore, I can say that the total kinetic energy acquired by the stone to reach level, the total kinetic energy acquired by the stone to reach level is going to be nothing but half mv square plus mgh. If I substitute these values, I will get the answer as 128.4 joules. Now let us assume that by the time the stone reaches level, that is either point P or point B, its velocity is v2. Let v2 be velocity at level. If v2 is the velocity at level, then the kinetic energy at level should be equal to 128.4. We already know the mass of the stone, so I can therefore say that the value of v2 when I solve this is going to be 64.2 meters per second. That is the velocity of the stone at point P. Now, what are the forces acting at it at point P when it is reaching level? One is going to be your centripetal force, that is mv square by r. At level, the centrifugal force is going to be mv square by r. Since it is at level, there is going to be no weight acting on the stone now. The weight of the stone is going to be 0. The weight component of the stone is going to be 0. Weight component is going to be 0. Therefore, total force is mv square by r plus 0. Why it's 0? Because see, the weight component is only in the vertical direction. Here, because of the tension of the string, it's in motion. So there is going to be no weight component. This is going to be due to the kinetic energy that it is going to move. It's only in upward direction and downward direction that you would have the weight component acting. Right? So you should get this answer as 128.4 newtons. Next, let's see the next sum, right? Take out next sum, please. A stone of weight 2 kgs. A stone of weight 2 kgs is moving in a vertical circle. A stone of weight 2 kgs is moving in a vertical circle of 1 meter. Find the velocity and the tension. Find the velocity and the tension at, first part of the question, highest point. Second part of the question, lowest point. Third part of the question, midway. Velocity at highest point. Guys, we've done this derivation. So if you just see the derivation, you should know that velocity at highest point is square root of gr, right? radius is 1 g we know, and tension at the highest point we have derived is nothing but tension at the highest point is going to be mv square by r minus mg, right? Now mv square by r minus mg at the highest point is going to be 0, because that is the minimum velocity that is given to the stone so that the stone just completes a circle. So tension at the highest point is going to be 0. Next, second part of the question says that at lowest point, velocity at lowest point. Now velocity at lowest point, I can say v2 is square root of 5gr. Again we've done this derivation, guys. Similarly, the tension at the lowest point is going to be due to the centripetal force as well as the weight of the string acting downwards. Centripetal force mv square by r, weight of the string acting downwards mg, right? Now this is going to be equal to 5 mg plus mg. Again we have done this derivation how mv square by r becomes equal to 5 mg. So this is going to be equal to 6 mg, right? Final part of the question, midway. Right? Midway the velocity is square root of 3gr and the tension is 3 mg. So substitute the values and you will get your answer. Right? We get this. Next, I think that was the last sum for the chapter. This finishes this chapter. We'll stop this here for the day. Thank you very much.